So what is IRR? It means that every investment, every business, every project has their own returns. They will give you a return. They will give you, what is it? They will bouncing back to you, right? Just like a bouncing a ball, they will return to you immediately. Okay. Let's compare to the another method, which is NPV. In NPV, we're just calculating a profit, right? But now we are calculating the returns. Okay, so some people feel that calculating the return is quite interesting. It's quite promising enough comparing comparing selecting or calculating the profit. Okay, let's say if you if you select A, the return will give 10%, let's say. Okay, and compared to plan B, the return will give you 50%. So it means it will give you 50% higher to your initial investments, which means 50% will be viewed as profit. So the IRR cannot stand alone. It will equate with another method, just like NPV, annual worth, and etc., and also payback period. So as an investor, we are going to use several methods at the same time. Yeah? Calculating the NPV, present worth, annual worth, payback period, sensitivity analysis, IRR. It's just like a common method, just like basic method in selecting the portfolio project or what is it, investments. Okay, so, and the most safest one, maybe some people say it is the safest one, the lowest risk one, is deposit amount of money in the bank account. It's just like saving amount of money, and every month the bank will pay to you. Okay, let's say 1% compared to your balance, your ending balance, because you only have to wait. You only have to wait until the bank gives automatically add to your balance. Okay, and some people say the safest one is just like purchasing gold or purchasing another instrument, and somehow you have to learn another instrument that will give you a highest return. But as a Muslim, you have to be careful because somehow it will give you it will give you disadvantage, yeah, especially for Muslim one. You have to be carefully, and then you have to know whether it will give what is it, syubhat one, ragu-ragu, ya. So you may avoid that instrument. And this is for Muslim. Okay, so the IRR means how speed the money comes back to you, right? So this is the simple definitions. And the IRR will exist only the NPV equal to 0. So this is the equations. So if you want to know the IRR number, so you have to make your NPV equals to 0. So we can calculating the exact value of IRR. And the IRR will be represented by an I star in this screen. Okay, so it may implement it in another situation, just like the present worth, annual worth, future worth. Okay, so okay, the equations or the formula is just like finding the net present value equals to 0 or annual worth or future worth. So you may choose one of them, and then it forces us to use a trial error methods. You know, the trial error means you adjusting a number that fit to the equations. Okay, we call it interpolations. Okay, we use interpolation in finding the noun I. Okay. So So this is I, the mysterious I. This is the unknown I, because we are going to guess the exact number of I. I represent IRR. Okay, IRR means how speed that money comes back to you. The highest IRR means that investment is promising enough. You may continue to use it. Okay. So now the IRR will be compared to MAR. So MAR stands for minimum attractive rate of return. Minimum means a very minimum effort. A very minimum effort that you will choose it better. So somehow MAR itself means that you select amount of money or investing a money by depositing in your bank account, in your commercial bank. Okay, so we call it MAR. So let's say, let's keep in your mind, you are inherited 500 million rupiah. So this is a very, what is it? Risky one, because you are still student and you are inherited 1,000,000 rupiah, yeah, 100 million rupiah. So after you learn the Indian economy, you know that there are two options. No, not just two options, three options. Do nothing will accompany to you in every situation, right? So there are two options. You study hard, you learn about the investment, and then it ends to two options, two alternatives. Okay, let's say leave the bank. No, leave the money in a saving account, because it will give you 6% for the returns over 10 years. So every month, now every year, the bank will pay to you about 6% from the initial investments. Okay, so this is MAR. We call it MAR, the very minimum effort. Now, you are challenged to open a steak restaurant that, after you calculated a lot of calculations, and then you do some interview research about opening the steak restaurants, it will give you 20%, 20 returns. It will give you 20% for the initial investment. So amount of your initial investment, among your saving at the first time, will purchasing to opening the restaurant, and then it will evolve 5 years. Okay, it will evolve 5 years, and then you will get the 20%. Okay, so now you are facing two different alternatives, and then you want to know which alternative is the most promising enough to be proceed, or what kind of portfolio that should be selected. And don't forget, do nothing will be accompanied to you. Yeah, will be just like another options in every situation, especially in feasibility analysis. Okay. Now, okay, you know that this is a very most popular steak, yeah, chef. Okay. So suppose you are inherited amount of many 100 million rupiah, and you're still students. And now the summary, we can jump to the summary. This business will bring a 20% rate of returns. We call it 20%. It will be calculated. Let's say it will be calculated that 20% that restaurant will give you 20% over 5 years, compared to the MAR 6% that you have to wait until 10 years later. Okay, so it means this business will result in net surplus 100 million. So we call it net present value, 20% from the initial investment, which is 500. Okay. So the decision criterion is just like if the internal rate of return is greater equal than MAR, then the alternative is deserved to be selected. So using an interpolations method in constructing a new data, we can know the certain point that that we assume that this is the internal rate of return of a certain criterion. Okay, so in these cases, what should we do? Okay, what should we do in finding the right investment? Okay, so after we know that this alternative offer the exact return, which is 6% and 20%, I will prefer to opening the steak restaurant because the IRR is greater equal than to the MAR. Okay, so opening restaurant will be the best options. And also the duration is quite attractive because you only have to wait 5 years and then you will gain a lot of profit compared to the MAR. We're just comparing to the MAR, not another options. Okay, perhaps opening the coffee shop is quite promising enough in this situation, right? A coffee shop, and then what is it? What kind of business? The laundry one. Okay. But in a pandemic situation, maybe another option is just like continue your e-commerce compared to the opening the restaurants, perhaps. Okay, now let's face with another practice problem. So let's say I purchase a machine for my bakery company, let's say 39 million rupiah, and then it will give you a return. Okay, so annual saving will be just like the returns. Okay, it will give you a constant number until 7 years of useful life. So every year you will get annual saving 7 million, and after that the machine will be sold after it reaches useful life. I can sell it again to the market and worth to 8 million. Now, if I just put in my investment to the bank, let's say this is my minimum effort, I don't want to take a purchase an option. I just pick that 39 million in my safest effort, which is depositing the amount of money in the bank. It will offer 8%. The return is 8%. You can consider 8% as an internal rate of return, or you can consider 8% as internal rate of return or MAR because it has slightly similar definitions. So does the baker's dough decision of buying a machine is profitable enough? So you can do a calculation. So basically you can implement three different formula: present worth, annual worth, or future worth. So maybe someone feels that present worth is quite the easiest one because present worth is just like converting all the situations, all the all disbursement, and also all the revenue will be converted to the zero positions, right? So IRR will be occur if the NPV equals to 0. It means present worth inflow equals to present worth outflow. Outflow means cost. Okay, inflow means any kind of earnings or revenue. So let's say I have 8 million. 8 million is a salvage value, right? So keep your mind, draw the illustration in your brain. Okay, let's do a quick illustration in your mind. We have a line, we have an arrow, we have a period, certain period, and then you know that the salvage value will be occur at the end of its useful life, and the salvage value will be located in the positive one, right? Keep in mind. And then I have 39 million. 39 million is your initial investment. You will put it at a 0 period, and the arrow is downside. Okay, now let's move to another compound factor. For those who occur at the future, in the future value, let's say salvage value, the best common, the best present worth factor is PF, which is PF. PF, right? Find present, yeah, belum selesai. Find present if future value is given. Iya, belum. Kan harus set dulu. 8%, and then we are going to guess the mysterious I, which is internal rate of return. Iya, nggak apa-apa, disimpan aja. Internal rate of return. And the number of period is 7 years. And then add 7 million, which is annual saving, right? The annual saving for Baker's Code. It will give you a return. The exact return is 7 million every year. So let's say you will have a constant arrow, okay, uniform arrow, and then you know that every arrow, every cash flow which has a uniform, a constant, and slightly the same number, we are going to put it the suitable compound factor, which is PA, the mysterious I, and the number of period is 7. And these calculations equals to outflow, which is 39. Why we put 39 only? Because it falls in the right positions, because in the exact position, this is the exact observations. Our observation takes the 0 positions, right? So we just put it 39 only. So in another engineering economy practice problem, you know that we are going to guess, we're just finding the equivalence of future, right? Or you are calculating, or you want to find in the equivalence of present. Now you want to know the I. Okay, so the calculation is not an easy thing, because you have to guess it. It forced to guess it, you know, it's just like doing some trial errors. Because our table, our compound table, didn't mention exactly the numbers. You have to guess it by using a very intuitive, intuitive method, you know. Let's say F million, PF, and then you have to find PF, okay? PF, I star 7. And then you have to find the duration of 7 at 7 million PA. Now let's see PA, compound factor, the mysterious I, and the duration still 7. So it's exactly in the same page, okay? In the same page, but you have to guess. You have to guess. Yeah, you have to guess the I, the exactly I. And the result, it should be 39. Okay, do some simplifications in this case. Okay, let's say, let's open your compound table right now. And you know that you can do some simplifications. Okay, some simplifications. And I already make some observations that the mysterious I, okay, this I, which is IRR, is located into 2 different interest rate of returns. So if you put 9% in these equations, which is 8 million PF, 9% 7 plus 7 million PA, 9% 7, It's approximately approach this number, which is 39 something, 39 8 80 39 606 something, right? Now, if I put 10%, it will give different number, 38. So it is around 9% to 6%, 9% to 10%, sorry. Okay, right? So maybe it's just like 9 point something. And we want to estimating the exact number of these mysterious eye or eye stars. So you know that estimating one point by guessing two different points, it means interpolations, right? Linear interpolation, finding the right gradient. Okay, now let's apply the gradients or interpolations formula. Okay, in interpolation. So this is the mysterious eye. This is the mysterious eye or eye star, and then we know that it is located in the 9 and 10%. So basically, it's not easy thing finding the two closest numbers. It's just like the intuitive one. Okay, maybe you will start from the 0, yeah, 0.5%, and then will be put it in that equation. Oh, it's still not reaching the closest one, and then finding again until you know that by your intuition that, yeah, this number is located into the closest numbers, which is 9% and 10%. Okay. Now let's apply to the, what is it? To the gradient one. Let's say this is the x1, 9%, which is the known. Yeah, this is known numbers. And then the present worth is 39. Okay, this is 39.6 something is applying 9% to the formula. Okay, and the result ends up to 39. And then this is the mysterious eyes because this number maybe is located between 9 to 10, right? So if the options say 10%, 11%, 50% is not correct, okay? You can consider to not choose that options. It's around 9% to 10%. Let's say in the meta, yeah, in the meta is A, say it 9.5, B 50%, C 80%. Perhaps you will jump to the first option, which is 9.5. You may ignore the rest of options. You know what I mean? Yeah. So 10% is 38 because 39 is located between these numbers, 39 and 38, or 9%, 9% to 10%. And then just applying to the gradient one or finding the slope, because you know that this formula is very powerful in industrial engineering, because in every calculation, especially for finding the minimum effort, the optimum situation, we're going to apply this formula. Okay, so x minus x1 divided by x2 minus x1 equals to y minus y1 divided by y2 minus y1. Okay, now this is the thing that we want to know. So x minus 9 divided by 10 minus 9 equals to 39 minus 39.6 divided 38 minus 39.6. Okay, just do some simplifications and divided the same numbers maybe. Okay, and then it will end to 9.43. Okay, so the internal rate of return of purchasing the machine is 9.43, and it's not the end of calculation because we are going to compare with the MAR. You know, MAR is our minimum effort. So the MAR says that if you invest your money only in the bank, it will give you 8% for the returns. So you know that the largest one is preferable and deserve to be selected. So compared to the MAR, maybe purchasing this machine is preferable, is worth it compared to just passive effort. Get it?
Get it, miss.
Okay. Okay, so since the I-star offers a larger number compared to the MAR, so the decision is continue. Just continue to purchase it. Don't worry. Okay. Okay, now if I apply another formula, let's say I'm going to use annual work, because in annual work, they will neglect the repetition. You know, if an alternative facing different useful life, you may consider to use annual work because you then have to implement the least common multiple factor for KPK, you know, for different alternatives. So I prefer to use annual work for that kind of situations. So basically, it's just the same. Everything should be equals to 0. It means every profit should be equal to 0, whether it's present, annual, or futures. In this case, annual inflow equals to annual outflow. Let's say, let's do some illustration in your mind. Okay, you have initial investment, a regular cash flow, you know, your upside cash flow, which is for profit one, and then at the end you will get a salvage value, which is 7 million. No, not 7 million, 8 million. Okay. Now, let's say if the observation takes annually, it means every annual cash flow will not be converted because this is our aims. So 7 million, you know, let's back to the case again. 7 million is your annual saving. Okay, it's already the annual one, and then you just done you just put it the same without its compound factor. So 7 million. So everything will be proceed, yeah. Everything will be proceed annually. Okay. So let's say our outflow is your initial investment, which is located in the beginning of time. I'm going to convert it annually. So I have to put AP instead of PA, right? AP, the mystery is I7. And then I got the salvage value, which is occur at the end of its useful life. After I reach my useful life, and then I can sell my machine again to the market, which is 8 million. In the future, I will get 8 million. And then that 8 million will be converted annually, evenly, distributed evenly along its useful life. Okay. We forced to convert it annually because we are using annual work formula. So do some simplification, but now it will change, okay? Because the compound factor will AF, not PA. You're just changing your point of view into AF and AP compound factor, right? I just do some simplifications and then you just change 7 million to another, what is it, another sign, and then we got these equations. So let's say, okay, it's not the easiest one. Yeah, I told you that finding the right position between two numbers is not an easy thing because you have to guess it. You have to do some trial errors. Okay, there's no option. You just have to implement the trial error one. Okay, and then these numbers, 8 something, yeah, time to its compound factor minus 39 time to times to its compound factor equals to 7 million, right? And then if you put 9%, it will give you a closest one. Don't put a minus here to this case because 7 million will be put in a different side. And then don't forget to put minus. So it means, okay, let's say just consider, just ignore the sign issue one. So 7 million. So it's around 9% and 10%, yeah? 6 point something and 7 point something. So it will be located in between this number. Okay. And do some calculations. Okay. 9% is minus 6. And the Mr. I's, this is our aim. Our purpose is finding the right X, which is I or R, is 7 million. And if I put 10%, it will give a different number, which is 7 point something. Okay, just do a calculation for linear interpolations. Okay, this is the same step as the previous one, and then it will come to 9.83%. And still, it's still larger than MAR, and the decision is still favorable. Got it? And now, if I use future word, so if I use future word, it means our future word inflow will be equal to a flow. Okay, so everything will be forced to convert it in the future. So it means if a cash flow is already in future in our observation. So our observation is in the future. We are in the future, people, right? So everything that will be that already in the future, it will just put it the exact number, which is for salvage value. Okay, salvage value is already in the future, so just put it 8 million only. Don't put it in another. Don't put with another compound factors. Okay. And then for 7 million, which is annually, you have to first it into annual. FA I star 7, and then for outflow, which is in the beginning of time, you have to. Iya, masih keras, masih lembut. Enggak, masih lembut. Masih lembut. Es krimnya masih lembut. FB, okay. Now just do a calculation, and still it's around 9% to 10%. And do the same step, and then it comes to 9.41%, and still it is larger than MAR. Do you know that every calculation gives different number, right? We have 943, and then 983, okay, and then 9.41, which is not consistent, right? But still larger than MAR. So to keep different numbers to give a more robust solution and more constant number at the end, now you have to proceed to use it incremental analysis. Oh, still this is quite tough, right? Now, this is the algorithm in incremental analysis. Okay. Just order the alternative ascendingly, and then do nothing will be your best options, and then estimate it the right, what is it, the unknown number, which is I star, will be compared to MAR. Belum, es krimnya belum selesai. Belum. Okay, now, so Baker's Co. plan to purchase a machine. There are two options, machine X and machine Y, and the initial investment offer different numbers also. Okay, but it has same useful life. Okay, if the case mentioned the same useful life, you will continue to use present word instead of annual word. Okay, you know that annual words is very applicable for that alternative which gives different period. Belum, jam 12. Okay. Oke, cobain aja sana. Sana. Okay, now I'm going to skip the illustration one. Just keep in mind, yeah. So this is the first step. Do nothing will be the best option in the first iterations. The second iteration, the first alternative will be beat, yeah, will be compared to the machine X. Do some sorting, which is the alternative should be sorted ascendingly, yeah. Compare, you will start from the lowest one to the largest one. Okay. So start with 4 million, which is for machine X, and then continue to machine Y. Okay. So instead of using, the graphical one, I prefer to use the table, because table will give you the easiest calculation in implementing the IRR. Okay, this is the year. The 0 period is investment, initial investment, which is 4 to 4 million. And for incremental one, this is the formula. You have to do some subtractions. -4 minus 0, which is still minus. But this is the constant formula. So every second column will be subtracted by the first column. Okay. So between the first year, first year to 9 year, still it will offer the constant annual cash flow, which is the revenue one. You know the revenue because it will give you a positive sign. So I can assume that this is positive, and then this is for revenue. And then do some incremental one, which is subtraction between the second column to the first column. And it will end up the same number for starting by the first year to 9 year, which is what, 1 million. And at the end, that the machine can be sold for 35 and do some incremental. Okay, just do some calculation here. And this information will be proceed to IRR steps, not this one. Now let's do a brief illustration in your mind. In the beginning, it will give you a minus sign, which is for initial investment, right? And then at the end of first year, which is start by first year to 9 year, it will a constant number, which has a positive sign, yeah, 1 million, positive million. It means I have an annuity one, and at the end I get also the revenue. Okay. The 35 derived from addition between the annual profit and salvage value. So we got 35. Okay. Okay, now the formula is 1 million PA, the mysterious I, 9, right? Because the annuity start from first year to 9 year. Okay. And then I have the salvage value and will be converted into present one. Okay. PF 9% 10. Okay. Yeah, be careful for durations because it will give you a different durations. Yeah. 10 and 1. And equals to 4 million because 4 million is our observation durations. This is our observations text in the beginning of time. And then, yeah, just do a trial error. Just do the trial error one, and then it will end up to 20 to 25. So around these numbers, between these numbers. Okay. And using a linear interpolation, it offers 24%. So, and the iterations say if the mysterious I or I star larger than MAR, then the purchasing the machine X is acceptable. Okay, not do nothing. So in this case, the machine X is temporarily as the winner in the second iterations. Okay, since the I star gives a larger number compared to the MAR, then the machine X is temporarily the winner. However, if the results say the reverse, which is, what is it? Let's check. Let's check the MAR. I forgot about the MAR. MAR is 9%, okay? Let's say in this calculation, it gives you 7%. And the MAR is like 9%. It means machine X is not profitable enough. So the winner is do nothing. So purchasing a machine X deserves to be selected in this case, yeah. So the machine X will be proceed to the third iterations. Machine X and machine Y recorded in order, and then the information is derived by the incremental information, not to the second column, okay? So machine X and machine Y, this is the informations, and then do subtractions between the machine Y information. All information in machine Y will be subtracted by the machine X. It means minus 12 minus 4, and it will end up to 8 million. Okay, don't forget to put the right sign because it will give you different information and also different results. Okay, 3 minus 1, and it will give you a constant information start from first year to 9 years. And then at the end of the time, you will have 2.5, which is, this is the additions of salvage value and its annual saving from machine Y. So it will turns out to 6 million. This is the additions between two numbers, okay? And don't forget, this is the machine X, yeah? Information of machine X 35 is derived by the addition of salvage value and also the annual saving from the machine X. So this information will be proceed to IRR calculations, okay? Not the second column, either of first column or second column. Just put the incremental situation. Okay. Okay, now this is the formula. Okay, you know that it's not the easy thing, yeah. Just use intuitive, intuitive method. Okay, and then it comes out that these numbers between 20 to 25, yeah, between these numbers. I don't know the numbers exactly, yeah. This is the now numbers, I don't know. And do the linear interpolations, and then the IRR say 22%. Since this number is still bigger than MAR, okay, and it will be compared to the MAR only, not the previous IRR. Although it will give you bigger in IRR, but still in the certain iteration, it will be compared to the MAR only. So since 22% is larger than MAR, which is 9%, then the winner of all iteration is machine Y. So machine X is not preferable in this case, so the conclusion is selecting machine Y. So in incremental analysis, why we put incremental analysis, why we implement incremental analysis, because it will give a constant, not a constant, a consistent, and this is maybe the suitable definition. It will give you a consistent number, okay? Compare if you use annual word, future word, or in wiki1. Okay, present word. And then for incremental analysis, you have to make a sorting. Yeah, you make a assortment. Okay, start by the lowest one, the smallest number one, smallest safety, smallest initial investment, and continue to the largest one. And do nothing will be the best option in the beginning of iterations. So do nothing will be compared to the smallest number of investment. And after that, if the IRR say it is bigger than MAR, and then do nothing is not preferable one. And for that investment, which is the result from the first iteration, will be compared to the next alternative, which has the largest one. And still, the criteria is you just compare to the beginning mark, which is 9% in this case. So the winner among all the situations is the final iteration, which is maybe the third iteration in this case. If the third iteration says that it gives you the largest one compared to the mark, not the previous IRR, it still gives you that this investment is the winner. It's the winner.